All right, man, lift it up. Watch the edge, watch the edge. Set her down right here. All right, lift her up, lift her up. Watch the alignment there. Keep moving, we got tanks coming through.
January 17th, 1944. A bitter wind cuts across the fields of northern France. Mud clings to the boots of German engineers as they trudge along a battered country road, scarred by tank treads and shell craters. Smoke rises from distant bombed-out villages, the scent of iron and wet earth heavy in the air. Ahead, something catches their eyes, a narrow strip of glinting steel stretching over the churned mud. At first, it seems impossible, a road freshly laid, yet every plank is uniform, perfectly aligned, stretching for miles. The men stop, squinting against the pale winter sun reflecting off the metal. No horse-drawn carts, no months of labor, just a road, ready to bear the weight of tanks, trucks, and endless convoys. One engineer mutters under his breath, disbelief threading his words. How could the Americans build this so quickly? How could they move men and machines over such inhospitable terrain in a matter of hours when it had taken them weeks to repair a single stretch of road? In that moment, German calculation meets American ingenuity. The war's logistical battlefield has just shifted silently but decisively. The planks seem to stretch toward infinity, a gleaming promise of mobility that would soon rewrite strategy. By the late 1930s, Europe's network of roads was a patchwork of centuries-old cobblestones, narrow country lanes, and damaged highways. In Germany and France, main arteries were often heavily traveled but poorly maintained. Secondary roads were little more than dirt tracks, prone to mud and flooding. For armies on the move, especially mechanized forces, this presented a constant challenge. Tanks, trucks, and artillery pieces were only as fast as the ground beneath them allowed. When World War II erupted in 1939, the limitations of this infrastructure became immediately clear. The German blitzkrieg in Poland revealed the advantage of armored divisions over static infantry, but it also exposed logistical vulnerabilities. Fuel trucks sank into muddy fields, supply lines stretched thin, and damaged roads slowed the advance of troops behind the spearhead. In preparation for future campaigns, engineers on both sides studied the lessons of Poland and later France, trying to find ways to keep armies mobile across hostile terrain. The Allies, in particular the United States, recognized early on that conventional roads would not suffice for the vast mechanized operations they envisioned. Unlike European forces, the U.S. Army had the advantage of industrial capacity, engineering expertise, and vast resources to experiment with novel solutions. American military planners understood that victory would not come from firepower alone, but from the ability to move men and material faster than the enemy could react. By 1942, the U.S. Army Corps of Engineers had begun exploring modular road systems, portable, prefabricated surfaces that could be deployed quickly over soft ground. The idea was deceptively simple. Instead of rebuilding broken roads, lay a temporary surface that could support the heaviest vehicles and be removed or reused as the front advanced. These steel mats, later known as Marston mats or pierced steel planking, PSP, were designed for versatility. Each panel measured roughly 10 feet long by 15 inches wide, with a lattice of holes to reduce weight while retaining strength. The panels could be connected like a puzzle, forming a continuous roadway capable of supporting tanks, trucks, and even temporary airstrips. At the same time, the U.S. military faced its own internal skepticism. European engineers, and even some American commanders doubted that such light, modular steel could endure the punishment of frontline use. Testing grounds in states like Florida and Arizona provided initial proof. Convoys of trucks and light armor moved across PSP roads with minimal wear. Engineers documented stress points, improved fastenings, and refined deployment methods. By the end of 1942, the concept was validated, but it had yet to meet the ultimate test: actual combat deployment in Europe or the Pacific. Meanwhile, the Germans, confident in their engineering traditions, continued relying on traditional road repair techniques. Their field engineers carried portable bridges, gravel, and timbers, meticulously patching damaged roads. These methods were effective, but slow. Every day lost to repair slowed troop movements, gave the Allies time to reinforce, and left the German front vulnerable to flanking maneuvers. It was a limitation the Americans would soon exploit with cold, industrial efficiency. As the U.S. geared up for the invasion of North Africa and later Europe, logistical planning became a central component of military strategy. Convoys would not merely deliver supplies, they would define the tempo of operations. Steel mat roads, designed to be deployed in hours rather than weeks, offered a tactical advantage no traditional army could match. They promised to transform muddy fields into highways of steel, shrinking distances between supply depots, forward units, and frontline operations. By January 1944, the groundwork was laid. Engineers had shipped thousands of steel mats to staging areas in Britain and North Africa. Plans for Normandy included detailed calculations of road placement, bridging gaps in French infrastructure, and ensuring armor divisions could advance without pause. For German engineers encountering these roads for the first time, it was a revelation, an almost surreal vision of mobility that would challenge every assumption about warfare in Europe. The stage was set. One side relied on centuries-old methods and painstaking manual labor. The other wielded industrialized innovation, delivering roads in days where traditional engineering demanded weeks. Soon, the planks of steel would become instruments of speed, endurance, and tactical surprise. The sight of these gleaming roads stretching over frozen mud, observed by astonished German engineers, marked the moment when logistics began to overtake brute force as a decisive factor in war. The groundwork for American ingenuity was complete, and the battlefield was about to change. While American engineers refined the concept of steel mat roads on domestic test sites, preparations were simultaneously underway to prove the system in real theaters of war. North Africa became the first proving ground. The desert, with its shifting sands and harsh heat, provided an unforgiving environment that could either validate or doom the concept. Engineers transported hundreds of tons of pierced steel planking, PSP, to forward depots, each panel carefully numbered and stacked for rapid assembly. The task fell to the U.S. Army Corps of Engineers 1st and 2nd Engineer Special Brigades. These units, trained in rapid construction, began laying temporary roads to support mechanized columns moving toward Axis positions in Tunisia. Convoys of trucks, tanks, and artillery pieces crossed the PSP surfaces with astonishing ease. Reports from the field highlighted the dramatic difference. Where sand had previously slowed vehicles to a crawl, the steel mat supported continuous movement. German forces, observing from the distant front lines, could scarcely believe the speed at which the Americans advanced. Simultaneously, the concept was adapted for use in Europe. Britain, anticipating the invasion of occupied France, became a hub for assembly and training. Thousands of American engineers practiced linking mats in sequence, securing them to soft ground and bridging natural obstacles like streams and shell-cratered roads. The modularity of PSP meant that engineers could lay a continuous roadway without heavy equipment. Each man lifted a panel and fitted it into place, connecting dozens in a single hour. This efficiency allowed for the construction of miles of road in a fraction of the time conventional methods required. The technical details were precise. Each panel weighed approximately 70 pounds and featured perforations to reduce weight and allow water drainage. Edges were reinforced to prevent warping under heavy loads, while cleats provided traction for tracked vehicles. Engineers developed specialized techniques for stabilizing the mats on soft or uneven terrain, including anchoring with steel pins or wooden stakes. Detailed manuals ensured that deployment could occur under combat conditions, day or night, without specialized machinery. These innovations transformed logistics into a mobile, flexible science. By mid-1943, the Americans had tested PSP in every conceivable environment: desert sands, frozen tundra, and rain-soaked fields. Reports confirmed that a standard engineer unit could lay nearly a mile of roadway in a single day under ideal conditions. This capability promised to outpace not only enemy forces, but also the natural limits imposed by weather and geography. Military planners began integrating steel mat road construction into operational strategies, linking airfields, supply depots, and front lines. The mats were no longer merely a convenience. They were a force multiplier. Meanwhile, German military intelligence grew aware of this innovation, but skepticism remained. Traditional European engineers relied on reinforced concrete, crushed stone, and timbered bridges. They could not fathom that American units could assemble roads in hours capable of bearing the weight of Panther tanks or 2.5-ton trucks. Early reconnaissance reports described thin steel strips being rapidly laid across mud, with heavy vehicles passing over without sinking. For German officers accustomed to slow, labor-intensive repairs, the efficiency seemed almost unnatural, a product of America's industrial might rather than tactical genius. By late 1943, planning for the D-Day invasion incorporated steel mat roads on an unprecedented scale. Engineers mapped out landing zones and inland routes, estimating the quantity of mats required to keep the advancing forces mobile. Aircraft carriers and cargo ships transported the panels across the Atlantic, ready to transform the shattered roads of Normandy into arteries of steel. Detailed coordination ensured that once the beaches were secured, engineers could deploy PSP to connect ports, depots, and forward units, enabling the rapid buildup of troops and supplies. It was in this careful orchestration, combining foresight, industrial production, and field-tested engineering, that the Americans achieved what German observers would later call astonishing. The modular roads were not merely a technical marvel. They were a symbol of strategic thinking in its purest form. Speed, adaptability, and simplicity converged, creating a tool that would allow Allied forces to move where the enemy least expected. When the first units laid steel mat roads in occupied Europe, the reaction from German engineers was immediate. Disbelief turned to fascination as convoys of trucks and tanks moved across freshly laid mats with no need for weeks of preparation. The Americans were not just repairing roads. They were redefining the concept of mobility on the battlefield. Every plank became a testament to planning, ingenuity, and a sheer industrial might that could bend the terrain itself to human will. And so, as the first steel mat roads stretched across France, the stage was set for a confrontation between traditional engineering and modern wartime innovation. German observers could only watch and calculate what it would take to respond. The battlefield of logistics had arrived, and it would soon shape the course of the war itself. 4 German engineers encountering the gleaming strips of steel for the first time, the experience was a mixture of disbelief and begrudging admiration. Accustomed to painstaking road repair reinforced concrete, and timber bridges, these men understood the labor required to make a road passable for heavy vehicles. Weeks of trenching, gravel laying, and shoring up soft ground were standard. Yet here, before their eyes, Americans were moving entire battalions over fields that had been impassable mere hours earlier. Letters and reports from German units note the astonishment. Eyes tracing the seamless joints between panels, hands brushing over the cold metal, wondering how it could support the weight of tanks. Some engineers even attempted to test the roads themselves, placing Panther tanks and 88mm artillery on the mats, expecting damage. Time and again, the steel held, an almost magical demonstration of industrial efficiency. Their shock was not merely technical, it was psychological. The rapid deployment of these roads suggested a level of preparation and foresight that the Germans had not anticipated, hinting at a broader American advantage in logistics. This human perspective captures more than curiosity. It reveals a moment where centuries of traditional engineering confronted the modern pace of mechanized warfare. For German engineers, it was clear the battlefield was no longer just a contest of firepower and strategy, but of ingenuity and speed. From a tactical standpoint, the impact of steel mat roads was immediate and profound. Armies move on their supply lines, and the ability to transport men, tanks, and artillery rapidly could determine victory or defeat. Traditional roads, torn by shell fire and weather, slowed advances and forced commanders to plan around terrain, often sacrificing momentum. The American steel mats changed that equation entirely. Once a beachhead or captured territory was secured, engineers could lay roads almost instantly, allowing armor divisions to advance without pause. Trucks carrying fuel, ammunition, and food could traverse mud and shell craters without sinking. The Allies could maintain the pace of their push inland, keeping the Germans on the defensive and unable to regroup effectively. Commanders began to see PSP as more than a simple convenience. It became a tactical weapon. The roadways allowed units to bypass destroyed infrastructure, reduce attrition, and maintain operational tempo. German reconnaissance reports noted Allied convoys moving in what seemed like continuous lines, a testament to the strategic advantage provided by these temporary but highly effective surfaces. The tactical edge was clear. Speed dictated initiative, and initiative dictated the flow of battle. By shortening supply lines and enabling rapid redeployment, the steel mat roads became an invisible instrument of dominance, shaping engagements long before the first shot was fired. The genius of steel mat roads lay in their simplicity and adaptability. Each panel, typically 10 feet long and 15 inches wide, featured a lattice of holes to reduce weight without sacrificing strength. Interlocking edges allowed for quick assembly and anchoring methods. Steel spikes, wooden stakes, or sandbags kept the mats stable even under the stress of tracked vehicles. Engineers had also innovated for diverse terrain. PSP could be laid over frozen fields, swampy areas, and freshly bombed villages. In deserts, it prevented vehicles from sinking into loose sand. In the mud of northern France, it provided traction for heavy tanks. The panels could be reused, moved, or repurposed for temporary airstrips, reflecting a modular mindset that contrasted sharply with traditional static engineering. Field manuals meticulously documented deployment methods. Teams of soldiers could lay miles of roadway in a single day, a feat unimaginable with conventional techniques. The mats represented a fusion of material science, industrial capacity, and practical design, turning logistical planning into an almost artistic science. Every hole, flange, and seam was calculated to balance strength with speed of assembly. The technology was deceptively straightforward, yet its application reshaped the battlefield. Where European engineers saw mud, rubble, and broken roads, Americans saw opportunity, a temporary surface that could transform inhospitable terrain into highways of movement. The elegance of the solution lay in its adaptability. Steel mat roads were not permanent structures, but instruments of mobility, crafted for a war defined by speed and mechanization. The success of steel mat roads was as much a triumph of leadership as of engineering. American commanders recognized early that logistics would be decisive in a war fought across continents and oceans. Unlike previous conflicts, World War II demanded rapid movement of mechanized forces over vast distances. Leaders such as General Dwight D. Eisenhower and Brigadier General Brian B. Somerville understood that battles could be won or lost in supply lines, long before artillery shells landed or tanks clashed. Decisions to prioritize modular road construction reflected this strategic foresight. Planning for North Africa, Sicily, and later Normandy required engineers to coordinate production, shipment, and deployment simultaneously. Factories in the U.S. produced thousands of steel panels, while military planners calculated exact routes, load capacities, and connection points. Leadership emphasized flexibility. PSP could be adapted for airfields, bridges, or temporary harbors, giving commanders freedom to respond to battlefield developments. Field commanders observed the results firsthand. Units that advanced over steel mat roads experienced fewer delays, maintained supply integrity, and sustained operational momentum. Leadership reports often highlighted these roads as force multipliers, acknowledging that a few hours of engineering could translate into days of operational advantage. This coordination between industrial capacity, engineering ingenuity, and tactical planning exemplified a level of strategic thinking that German forces had difficulty matching. For German engineers and commanders, steel mat roads presented a perplexing challenge. Reconnaissance teams reported rapid Allied advances in areas previously thought impassable, where mud, shell craters, and destroyed infrastructure had once slowed mechanized divisions. Convoys moved with near-continuous flow. German field reports expressed both confusion and alarm. What appeared to be temporary, fragile roads bore the weight of heavy tanks without fail. Attempts to counter the innovation were limited. Blowing up sections of road had only a temporary effect. Engineers could replace or reroute panels quickly. Mines and obstacles posed some hindrance, but the American speed in laying new mats reduced the window of vulnerability. From Berlin to the front lines, German officers debated whether the steel mat roads represented an engineering trick, superior industrial output, or both. By the summer of 1944, reports from the Eastern and Western fronts acknowledged that Allied logistical ingenuity was creating operational problems no traditional defensive strategy could fully anticipate. The German perspective underscores the asymmetric nature of this technological innovation. While tanks, artillery, and infantry were expected to dominate the battlefield, it was mobility and supply innovation, often invisible until the moment of encounter, that proved decisive. Steel mat roads shifted the balance in ways German engineers had not foreseen, challenging assumptions about speed, preparation, and adaptability. The psychological impact of steel mat roads on Allied troops was significant. Soldiers advancing over freshly laid PSP roads felt a sense of reliability and momentum that could be measured in morale as well as speed. For men wading through mud or trudging over destroyed villages, the gleaming lines of steel offered not just a practical solution, but reassurance. The Army's engineers had already solved the problem of movement. Convoys flowed continuously, artillery arrived on time, and supply depots remained connected, reducing anxiety about delays or isolation. This boost extended beyond the front lines. Commanders reported that troops who relied on steel mat roads displayed higher confidence and aggression, knowing that mobility would not be the limiting factor in an offensive. Engineers, likewise, took pride in their role, understanding that every panel laid directly contributed to operational success. The morale benefit was subtle but undeniable. It reinforced the belief that the war could be fought and won through preparation, ingenuity, and coordinated effort. Even for German troops observing from across the battlefield, the psychological effect was profound. Witnessing entire divisions move unimpeded over mud and rubble, the enemy recognized that Allied forces could execute operations faster than traditional defenses could respond. The steel mat roads symbolized not just physical mobility, but the mental advantage of an opponent who had mastered logistics as a weapon. June 6, 1944. The beaches of Normandy were a chaotic tapestry of men, machines, and fire. Amid the roar of artillery and the thunder of landing craft, American engineers carried the quiet promise of a new kind of mobility, steel mat roads. While infantry and armored divisions fought to secure the beaches, these engineers began a race against time, laying Marston mats across broken dunes, cratered farmland, and fields churned to mud by shell fire and rain. The operation was unprecedented. Tens of thousands of panels had been shipped across the channel, stacked along the beaches in precise order. Engineers, working in teams of 12 to 20, lifted each 70-pound panel, interlocked it with its neighbors, and anchored it into the soft earth. Within hours, pathways capable of supporting jeeps, trucks, and even M4 Sherman tanks were forming, allowing the first waves of mechanized units to move inland without waiting for repaired French roads. The tactical significance was immediate. Convoys that might have taken days to traverse shattered fields were now moving in hours. Fuel trucks reached frontline units. Artillery pieces were repositioned with unprecedented speed, and infantry could follow mechanized columns without delay. Commanders noted the transformation in operational tempo. Divisions that once advanced cautiously, wary of bogging down, now pushed forward with confidence. For the first time, the idea of a mobile, self-sustaining advance through hostile terrain became reality. German engineers, observing from prepared defensive positions, could scarcely comprehend what they were seeing. In some sectors, panzer divisions attempted to exploit broken terrain, expecting to slow American columns. Instead, armored units rolled over steel mat roads as if the mud and shell craters did not exist. Reconnaissance reports reached German high command describing roads laid overnight, capable of supporting the heaviest Allied tanks. Confusion gave way to alarm. The innovation had become a battlefield multiplier. The success of Normandy was only the beginning. By mid-July, engineers had extended steel mat road from beaches to inland supply depots, connecting ports like Cherbourg to forward units. Every mile laid allowed artillery and armor to respond faster than German forces anticipated. Tactical plans that relied on slowing the Allied advance were rendered obsolete. Supply lines were no longer a limiting factor. The Americans could sustain rapid offensives, reinforcing units and supplying them in real time. Operational efficiency was staggering. A single engineer battalion could lay up to 3 miles of road per day, keeping pace with advancing armored divisions. Bridges over streams or shell craters could be augmented with PSP planks, allowing convoys to continue moving without detours. In one documented case, a Sherman tank battalion crossed a previously impassable field within hours of the engineers' arrival, maintaining the momentum that would eventually lead to the breakout from Normandy. The psychological impact was equally profound. Soldiers moving over the gleaming steel felt an almost surreal sense of certainty in an uncertain battlefield. Engineers knew their work mattered as much as the artillery or infantry in achieving strategic objectives. For German observers, each panel represented not just a physical road, but a reminder of the Allies' industrial and logistical advantage, a warning that the traditional methods of slowing an enemy were no longer sufficient. At the same time, commanders on both sides realized the implications beyond Normandy. Steel mat roads were no longer just a tactical convenience. They were a strategic instrument. By reducing the time required to connect beaches, depots, and frontline units, the Allies could concentrate forces rapidly, outflank German defenses, and maintain initiative. The battlefield was now defined not only by where men fought, but by how quickly roads could be built and supplies delivered. In essence, the first operational deployment of steel mat roads marked a turning point. Traditional defensive calculations, based on the assumption that terrain would slow an army, were rendered obsolete. Mobility was no longer limited by mud, shell craters, or destroyed infrastructure. American engineering had created a force multiplier, invisible to the untrained eye, yet decisive in effect. The war was being fought not just with weapons, but with logistics and foresight. And as the first columns of tanks and trucks rolled smoothly across Normandy's steel arteries, German engineers faced the undeniable truth. The Allies had mastered a battlefield they could not contest, reshaping the war before a single major engagement inland had concluded. By July 1944, Normandy's front lines had stabilized into a deadly stalemate, yet the Americans' use of steel mat roads continued to accelerate their operational tempo. What began as temporary pathways from the beaches had evolved into a network of inland routes, connecting supply depots, fuel points, and artillery positions across churned fields and devastated villages. Where traditional road repairs would have taken weeks, engineers now laid miles of PSP in a single day, ensuring the steady flow of tanks, ammunition, and food. The logistical advantage was staggering. Entire armored divisions, which would have previously faced delays of 48 to 72 hours due to mud and shell-cratered roads, moved uninterrupted. Convoys carrying artillery shells and fuel arrived at the front lines precisely when needed, maintaining momentum for the breakout towards St. Lo and Cannes. Engineers even improvised crossings over bombed bridges by layering steel mats to create temporary thoroughfares, a testament to both adaptability and speed. German commanders struggled to respond. Field reports from the Wehrmacht described roads that appeared overnight and convoys that advanced as if terrain and battle damage did not exist. Attempts to disrupt these supply lines with artillery or air raids proved limited. The engineers could repair or reroute the mats faster than the Germans could destroy them. Some panzer divisions were forced into unplanned engagements, arriving late to critical points due to the constant mobility of Allied columns. The very advantage of German experience with terrain and engineering was neutralized. In operational terms, steel mat roads allowed the Americans to concentrate forces where German defenses were weakest. Rapid mobility meant that divisions could be repositioned overnight. Artillery could support attacks with precise timing, and infantry units were never isolated. The battle rhythm of the campaign shifted. Speed, coordination, and flexibility now dictated the outcome, rather than static fortifications or numerical superiority alone. One notable example occurred during the push toward Avranches in late July. Engineers laid continuous steel mat roads from the Cherbourg Peninsula to forward supply depots, allowing multiple armored brigades to advance simultaneously. German attempts to block roads with demolition charges were quickly countered. Engineers removed damaged panels and replaced them in hours. By the time German reinforcements arrived, the Americans had already outflanked the defenses, exploiting the mobility the mats provided. Beyond direct combat, the steel mat roads also allowed for rapid medical evacuation and repair of damaged equipment. Field hospitals could be supplied efficiently, and broken vehicles could be towed back to repair depots without delay. The psychological advantage for Allied troops grew as a result. They moved with confidence, knowing that logistics would not fail them. Conversely, German units became increasingly frustrated, their defensive calculations undermined by infrastructure they could neither predict nor control. The cumulative effect was profound. In a matter of weeks, steel mat roads transformed the Allied advance from cautious progress into a near-relentless push through Normandy. By late August 1944, Allied forces had liberated vast swaths of French territory, a success owed as much to mobility and logistical foresight as to firepower or numerical strength. The combination of industrial production, engineering skill, and strategic planning had produced a force multiplier that German forces could not counter effectively. By the time Allied forces crossed into Brittany and central France, the impact of steel mat roads was undeniable. The innovation had redefined operational planning. Speed of movement, flexibility, and rapid supply became as decisive as artillery, tanks, and infantry. American engineers had turned temporary planks of steel into instruments of strategy, reshaping the battlefield and forcing the enemy to confront a new reality where terrain no longer dictated pace. As German commanders observed from retreating positions, a realization settled in. The Americans had created an infrastructure war within the broader conflict, a battle where speed, planning, and adaptability could determine victory before guns were fired. The first deployment had been a tactical success. Sustained use had transformed it into a strategic game-changer. And with the Allied advance continuing unabated, it became clear that this innovation, modest in appearance but monumental in effect, would not only alter the course of Normandy, but also influence how armies would think about mobility, logistics, and engineering for the remainder of the war. By September 1944, the impact of steel mat roads on the Allied campaign in Western Europe was unmistakable. Where months of cautious advance might have been required to navigate destroyed roads and shell-pocked terrain, American and British divisions moved with unprecedented speed. The temporary steel highways, initially deployed along the beaches of Normandy, had become a sprawling network linking ports, depots, and frontline units. Convoys rolled uninterrupted, tanks surged forward, and artillery could be repositioned within hours, not days. The German military was forced into a reactive stance. Armored units that might have been strategically concentrated were delayed or diverted, unable to anticipate the speed of Allied movements. Field reports from German engineers noted strips of metal bearing entire divisions where no road should exist, a testament to the shock these innovations inflicted on the enemy. Attempts to sabotage or destroy sections of road yielded minimal results. In many cases, engineers simply replaced damaged panels in a matter of hours, restoring mobility almost immediately. Logistically, the effect was quantifiable. Allied planners reported that convoys carrying fuel, ammunition, and supplies traveled 30 to 40% faster than over-repaired traditional roads. Tanks and trucks no longer suffered immobilization due to mud or shell craters, reducing losses and maintenance requirements. The rapid deployment of steel mat roads enabled the establishment of forward supply points closer to the front, allowing sustained offensives without the delays historically caused by terrain. The human dimension of the aftermath was equally notable. Allied troops, moving over steel mat roads, experienced a psychological boost. Confidence in movement, supply reliability, and operational continuity reinforced morale, translating into steadier advances and more aggressive tactics. Conversely, German forces faced mounting frustration. Defensive plans that relied on delaying actions were repeatedly nullified, and morale suffered as armored units arrived too late to respond to fast-moving Allied columns. One striking example occurred during the breakout from St. Lo. Engineers had laid miles of steel mat roads connecting the beaches to inland supply depots, allowing armored brigades to advance rapidly and exploit weak points in German lines. The effect was a cascading operational advantage. Artillery could support flanking maneuvers. Infantry reinforcements reached objectives in hours instead of days, and German defensive positions were outflanked before they could stabilize. The roads, silent and unarmed, had become a decisive tool in shaping battlefield outcomes. Statistical reports underscore the scale of impact. By the end of the Normandy campaign, over 200 miles of steel mat roads had been laid in the European theater. Thousands of panels were reused across multiple fronts, from beaches to liberated towns, ensuring continuous mobility for armored and mechanized units. Casualty reports indicate a reduction in vehicle immobilization and supply delays, showing that the innovation saved both men and material. Even the Allies' adversaries acknowledged the significance. German after-action reviews specifically cited rapid Allied movement, enabled by temporary infrastructure, as a major factor in the collapse of their defensive lines. Engineers who had trained in traditional methods were forced to confront a new reality. The speed and adaptability of American logistics could not be matched by conventional means alone. In operational terms, steel mat roads had done more than allow faster movement. They had redefined the tempo of war. The initial shock seen by German engineers on the beaches had evolved into a sustained advantage that shaped engagements, dictated strategy, and allowed Allied forces to maintain initiative throughout the campaign. Mobility, once constrained by terrain and destruction, became an instrument of victory in its own right. As the front lines moved eastward and France began to be liberated, it became clear that the legacy of steel mat roads would extend beyond immediate tactical gains. They had proven that innovation, preparation, and adaptability could decisively shape outcomes, foreshadowing the broader strategic advantages that would carry the Allies toward Germany itself. The legacy of steel mat roads extended far beyond the immediate battles of Normandy and northern France. Military planners quickly recognized that these modular, rapidly deployable surfaces were not merely a temporary expedient. They represented a new paradigm in engineering and logistics. Their success forced a reevaluation of mobility, infrastructure, and supply strategies across modern armies. In the immediate post-Normandy period, U.S. Army engineers replicated and expanded the use of PSP in subsequent operations. In the Ardennes, during the Battle of the Bulge, steel mat roads helped maintain supply lines over frozen, snowbound terrain, preventing delays that could have stalled advancing units. In the Pacific Theater, where jungle mud and coral reefs hindered movement, steel mats enabled the rapid construction of airstrips and transport routes on islands such as Saipan, Tinian, and Iwo Jima. Their versatility demonstrated that a single technological innovation could be adapted across vastly different environments, providing consistent strategic advantage. Beyond tactical and operational applications, steel mat roads influenced military doctrine. Allied staff officers incorporated rapid deployment infrastructure into operational planning as a standard consideration. Mobility was no longer constrained solely by terrain or weather. It became a calculated variable in campaign design. Engineers were trained not just to repair existing roads, but to anticipate the need for temporary, modular surfaces that could transform a battlefield. Logistics was elevated from a supporting role to a primary instrument of strategy, and the lessons of Normandy became foundational for post-war military planning. The influence of PSP extended into post-war reconstruction as well. European countries, devastated by years of occupation and combat, faced the challenge of repairing destroyed transportation networks. Temporary steel mat roads allowed essential supplies, construction materials, and emergency services to reach remote or damaged areas. Their deployment demonstrated how military engineering innovations could be repurposed for civilian reconstruction, bridging the gap between wartime necessity and peacetime recovery. Urban planners and engineers studied the methods pioneered by the U.S. Army, recognizing the value of modular, flexible infrastructure in crisis situations. Technologically, the success of steel mat roads inspired further innovation in prefabricated infrastructure. Designers experimented with lighter alloys, interlocking designs, and portable bridges, leading to post-war advancements in military and civilian modular construction. The principle was simple but powerful. Speed and adaptability could achieve results that traditional construction methods could not. These lessons informed Cold War-era engineering, disaster response planning, and even temporary roadways in developing nations decades later. Strategically, the use of steel mat roads reinforced a broader truth about modern warfare. Industrial capacity and ingenuity could shape outcomes as decisively as tanks or artillery. By controlling mobility, the Allies dictated the tempo of battle, forced the enemy to react, and maintained initiative in ways that traditional strategies could not anticipate. German commanders, having faced the system firsthand, recognized its significance but were unable to counter it effectively. The experience demonstrated that innovation in logistics could yield a multiplier effect, influencing everything from frontline tactics to overall campaign strategy. Ultimately, the aftermath of steel mat road deployment was both practical and philosophical. On the ground, thousands of tons of steel had carried troops, vehicles, and supplies across landscapes that would have been impassable. In the planning rooms and command centers, the innovation had reshaped thinking about mobility, engineering, and the integration of industrial capability into military strategy. And in the broader scope of history, it left a lasting lesson that even modest materials, strips of steel, perforated and interlocked, could become instruments of strategic power, changing the course of war without firing a single shot. The stage was now set for reflection. The campaign had been won in part because of ingenuity, preparation, and logistics, not just firepower. The planks of steel had quietly rewritten the rules of mobility, leaving a legacy that would echo long after the war ended. In the quiet aftermath of war, the planks of steel stretched across fields and villages, a silent testament to ingenuity. They carried no banners, fired no shells, yet they had moved armies, reshaped battlefields, and forced even the most experienced engineers to reconsider what was possible. Steel mat roads were more than infrastructure. They were a demonstration of human foresight, of industrial capacity harnessed with precision and purpose. The shock felt by German engineers in Normandy was emblematic of a broader truth. Warfare is not solely won with weapons, but with the ability to move, supply, and sustain forces across unpredictable terrain. Where mud, craters, and destroyed roads once dictated the limits of strategy, a few sheets of perforated steel could redefine them entirely. Every mile laid, every convoy supported, became a symbol of planning and preparation, translating directly into advantage on the battlefield. Beyond immediate military outcomes, the innovation revealed a philosophical insight. Adaptability and ingenuity are as decisive as brute force. The Americans' capacity to anticipate challenges, to design solutions that worked in deserts, frozen fields, and war-torn villages, reflected an approach to problem-solving that extended beyond war. The same principles would influence post-war reconstruction, disaster response, and engineering around the world, leaving a legacy of flexibility and efficiency born from necessity. Yet, amidst the calculations, convoys, and maps, the human element remained. Soldiers advancing over steel-mat roads felt confidence. Engineers taking pride in their work knew the direct impact of their labor. Even the enemy recognized the power of preparation. The war had demonstrated that foresight, combined with resource and creativity, could tilt the scales of conflict. In the end, these simple strips of steel remind us that innovation can be subtle, quiet, and decisive. They show that human ingenuity, when paired with organization and determination, can move not only machines, but history itself. The gleaming lines stretching across mud and rubble were more than roads. They were pathways to victory, proof that in war, as in life, preparation and imagination often matter as much as courage or firepower. And in that lesson lies the enduring legacy of the steel mat roads, a reminder that even the humblest tools, thoughtfully applied, can change the course of history.